In this demonstration, you'll learn how to take a standard Fluent case file with input and output parameters and perform a parametric analysis entirely within the ANSYS Fluent environment. In this case, you'll analyze a 3D mixing tank case from Fluent. The temperature and velocity at the two inlets of the mixing tank are input parameters that are already defined in the Fluent case file. The case file also contains a surface report definition to monitor the average temperature at the outlet that's also defined as an output parameter. We'll start Fluent in 3D with 4 processors. Subsequent sequential runs will also be utilizing 4 processors each. In the Open Fluent session, we'll read in an existing mixing tank case file that already contains input and output parameters and a surface monitor. Once the case is loaded, get started with the parametric analysis. In the Parametric tab of the ribbon, under Study, select Initialize. The parametric analysis requires you to manage various files from potentially numerous separate Fluent calculations. Fluent will help manage these files using what is called a project file. Since this is a new parametric analysis, you'll be prompted to first get started with a new project. In this case, use the default name for the project based on the loaded case file. You can also use the parametric ribbon for creating and updating design points and other useful tools for handling parametric studies. Aside from the ribbon, you are presented with an enhanced outline view, with a case view and a parametric study view. The case view displays the currently loaded case, or base case design point, also known as the base DP. The parametric study view provides access to the design point table and parametric reports. The parametric study itself is a separate tab alongside the graphics window and consists of the table of design points. Right now, the table only contains the baseline design point. You can also choose to view the current case parameters if you wish. Get started by adding a design point, either in the ribbon or in the parametric study view. Add more design points in the same way. Change the values of the first inlet's velocity so that they incrementally get higher for each design point, and enable their data to be written in each case. Depending on what the final objectives are, you may choose to write, not write, or partially write select design points. Update all of the design points by clicking Update All in the ribbon under Update Options. Monitor the status in the table and in the progress bar. Design points are updated sequentially using 4 processors each as set in the Fluent launcher. For each value of the inlet velocity, new values for the output parameters are calculated. A new solution is calculated, values tabulated, and files populated and managed through the Fluent project. Once all design points have been updated, the table looks like this. Now that the analysis is complete, we can explore simulation reports. Double-click Design Points Report Settings in the Parametric Study view to display the Simulation Report Outline task page, or you can use the ribbon. Review the available options for the current report. We can choose to generate a simulation report for the base case or for any of the other design points. For this demonstration, we'll select DP1 Report and click Generate. Note that the initial generation of a report may take a few moments. However, subsequent reports will later take less time. The report will be generated and be displayed in its own tab in the Fluent interface. We can also generate a separate simulation report that is dedicated to the parametric study itself, where results from all design points can be studied at once. So we'll select Parametric Report, keep the default report settings, and click Generate to create a parametric report. Once the parametric report is generated, you can compare the mesh, contour, vector, or path line plots, or combinations thereof using scenes, comparing the plots between the various design points. For instance, here we can see how contour plots of temperature along the inlet plane change as the first inlet's velocity changes. Comparisons can be made in the same report, such as comparing the results between 2 design points, such as the contours of the outlet temperature, or the temperature distribution along the mixing tank walls. You can also analyze data from your parametric study using comparison plots. You can create a new plot from the ribbon or the parametric study view to open the Parametric Plots dialog box. Here you can specify the X and Y axes of the proposed plot, then see the results in the Fluent interface. For instance, here we can see the changes of the inlet velocity input parameter versus the outlet temperature output parameter. As you can see, Fluent provides a powerful and comprehensive capability to study the fluid dynamic effects of parametric changes all within the Fluent environment. This concludes this demonstration of setting up and solving a parametric study in ANSYS Fluent.